Hi, my name is Jill Gabbert. I'm the Operations Director for CSIA. Welcome to this Masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help SIs build better businesses. How do we do that? Well, for starters, we have a team of volunteer SIs who have crowdsourced a best practices manual to help SIs scale their businesses. In fact, the BP committee just released a beta version of the latest manual, 6.1. CSIA also offers a certification program and other resources, including professional development, learning from peers, and access to vetted professional services companies, including insurance and legal, who understand an SI's unique business needs. For partner members, CSIA offers an ecosystem to help grow your SI programs, understand your customers' pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events, other resources from accounting to sales to operations 365 days a year. It also means you and your team can attend the CSIA conference because this annual in-person event is members only. If you are currently a member, thank you. If you want to just get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation. It's a great way to hear what your peers are up to. One last housekeeping note before I turn it over to today's speakers. If you have any questions during the presentation, please use the Q&A feature in Zoom. That helps us stay organized. This session is being recorded, and you will get a link to the recording in the next day or so. Today, we will hear from two companies on the forefront of edge computing and network security, OnLogic and Patero. OnLogic designs and manufactures industrial and rugged computers for the edge. Patero provides software crypto modules that make data flows to and from OnLogic edge devices quantum safe, protecting critical data today and into the quantum future with NIST's new cryptographic standard just released this past August. At this time, I'd like to turn it over to today's speakers, Matt and Crick. Take it away.
Thank you, Jill, for that introduction, and thank you to the folks and community with CSIA for having us today. We're very excited to talk to you. My name is Matt Smith. I'm a sales manager here at OnLogic. I've had the pleasure of being at OnLogic for 6 years as of yesterday. In addition to my manager duties with the customer success team on our sales team, I also have responsibility for our integrator program, which really focuses on building and growing the relationships with our systems integrators. Really excited to talk to you today, and I'll let Crick introduce himself.
Hi, good morning, everybody. I'm Crick Waters, CEO of Patero. I bring a long background from engineering and manufacturing operations, control systems management in industrial applications, into artificial intelligence for manufacturing operations. And now at Patero, we're working on securing the data flows from edge to anything. And we have many customers in multiple domains. And this is a very important topic, and as you will learn. So I'm looking forward to revealing some of this information to you.
Thank you, Crick. And before we get started, I would like to just quickly go over what you can expect to learn and see from us today. So here's our agenda. We're going to talk about the growing importance of the edge. We're going to talk about your data security and how it might be threatened. What solutions are available to address those threats? Where do integrators like yourselves fit into the solution? And we'll, of course, leave time at the end for any questions that you might have about what we've presented. So that's what you can expect to learn. So I'm going to cover just a little bit about the growing importance of the edge. So before we can advise you on how to protect the edge, we need to first define it. So what is the edge? You likely use the term daily. You're already implementing solutions at the edge every day. The edge is some of the pictures that you see on your screen here. It could be vision and sensing systems that are aiding quality control in a processing or manufacturing environment. It could be predictive maintenance using 3D LiDAR technology at a raw material mining plant to prevent costly downtime. It's also industrial control for a large steel mill to ensure equipment is running smoothly and efficiently at all times. It's also machine vision and robotics manufacturing controls to ensure a production line meets modern industrial 4.0 standards. The edge is where data in the field begins its journey. The edge is a place. The edge is what keeps our most critical infrastructure connected. And so the edge, as you work with it every day, may feel far, but really the edge is the beginning and your connection to potentially anything. The edge is everywhere. We also really want to highlight that computing is moving to the edge as well. To really highlight the edges everywhere, we'd like to show you the data that actually proves that it's only increasing. The graph on your screen visualizes the compound annual growth rate that projects a nearly 37% increase in the need for computing at the edge over the course of an 8-year time period. Now, this data only goes back to 2022, and even still, you'll see the doubling, if not tripling demand every 2 years. And we, of course, expect this to grow and continue well beyond 2030 as our infrastructure advances. So as we see more adoption of these solutions supporting our critical infrastructure, it stresses the importance of implementing reliable and secure solutions. I will click happy there. Apologies.
All right.
And before that, sorry, Rick, the mouse control took over there.
There we go.
There we go. So on your screen, you'll find our edge gateways separated into 4 primary categories that cover a wide range of fitment, features, and functions depending on the application and environment. Like the examples I mentioned previously, the edge is often a dirty, dusty, remote, and challenging environment. So we have specifically designed hardware solutions to be wherever our customers need us to be. We are wherever industrial and ruggedized computers are needed, just like, again, the examples that I showed you previously. So with the increasing need for compute at the edge, like we saw in the graph, OnLogic is ready to help you solve those complex challenges with reliable hardware solutions and great software partners like Patero. And so now that I've defined what the edge is, how its footprint is rapidly growing, and how OnLogic can support you, we'd like to shift our focus to how the valuable data you've just installed at the edge. And I'll turn it over to Craig to talk about Patero.
Okay, so let's talk a little bit about what's going on with data security and why it's relevant to the edge. So a little background here, so I can get this guy to go. Let's talk about the first problem. And I call it the security of everything, but really focused on what we started with the Internet of Everything in 2012 when Cisco coined that expression, the industrial Internet of Everything or the Internet of Everything. And since that time in 2012, globally, we've experienced a 600% annual growth in what could be considered the vulnerable cloud attack surface. And that's really due to the implementation of data flowing from edge devices into cloud applications. This vulnerable cloud attack surface, the vulnerability is because it's exposed to the wild of the internet. And what we're doing now with the deployment of edge computing for AI and ML at the edge, we're increasing that attack surface, but we're also increasing the value of the data because it's now a complex data and interpretation and so forth. And that growth of the attack surface due to edge computing is significant at almost 37% compound annual growth rate. So problem one, the security of everything in the vulnerable cloud attack surface, is already large and increasing. In fact, it's such a significant attack surface that the National Security Agency, with the FBI and CISA, came out with this month a joint announcement called, Russian military cyber actors targeting U.S. and global critical infrastructure. And what they have found is that the Russian military, the GRU, is scanning 26 NATO country domains, and they've done this over 14,000 times. What they are looking for are vulnerabilities in that cloud attack surface. If they can find a responsive port and they can negotiate with that port to allow them in or reduce the security protocol that's being used by having a weak TLS, for example, they can attack that critical infrastructure. So that's part of the problem. The next problem is that the classical cryptography, even if it's properly implemented, is technically obsolete. And I'll tell you a little bit about what that problem is. Peter Shor is a guy, brilliant mathematician, who really set the wheels in motion for this. And back in 1994, Peter Shor developed an algorithm that, in theory, could be used if a quantum computer existed that could do what we call factoring of prime integers. That math problem, factoring of prime integers, is the fundamental math problem that's used in all asymmetric encryption. So things you're familiar with, HTTPS, RSA, PKI. Effectively, with Peter Shor's algorithm and a theoretical quantum computer, we could crack encryption. So that's how the wheels got started. And then what happened is that quantum computers became a true thing. And so the first one, 4 years later, after Peter Shor wrote his algorithm, was in 1998. In 2001, IBM actually used a quantum computer and Peter Shor's algorithm to crack encryption. And since that time, we have accelerated the growth of quantum computers. And you probably read about it now, but you probably don't read is that the Chinese reported breaking RSA encryption with just the 372 qubit computer at the end of 2022. So the threat is real. The investment in quantum computing is tremendous. In fact, China itself is investing 8 times what the US is investing. It's just billions and billions, $15 billion is what China is investing. So what does that mean today? Today, it means that the data that you're sending from the edge to the cloud may look like something like this, just encrypted data. If somebody steals it now, they may not be able to interpret it because it's using classical encryption. But if they have that data later, not too long from now, they'll be able to decrypt that data and derive from it your company secrets, financial projections, new product developments, trade secrets, software source code, things like personal data, driver's licenses, social security numbers, wills, estates, and all kinds of government secrets. We call this the steal now, decrypt later problem. We know that data is being harvested by state actors globally across all critical infrastructure functions because they will be able to decrypt it. And so this is the big warning that the US government has put forward and has in fact mandated a national encryption upgrade. The US government, NIST, National Institute of Standard Technology, started a program 8 years ago to develop a new math problem that could not be or not easily be solved with Peter Shor's algorithm. That new algorithm, what they did is they introduced 90 plus potential candidate math problems, and over 8 years have worked diligently to derive one. And in August last year, they finally announced standards which can be used in new encryption modalities that are resistant to quantum computers. So in the US government, starting with the White House and with going through Congress, have issued a series of memorandums and directives, including a national cybersecurity strategy, that are causing the transition to a post-quantum world. This NIST standard, which was issued in August 2024, was really the starting gun for this whole thing. And Dustin Moody, the guy who runs the whole program for NIST, in his release in August that system administrators need to start integrating immediately. And so that's where we are. And we think it's going to take quite some time to go through and implement post-quantum cryptography across all different industries. We start with the US government. The Office of Management and Budget is going to direct agencies to develop a migration plan, and they have to do that now. So in 2025, there will be the beginning of the implementation of the transition from classical encryption to post-quantum encryption. The government's estimating at least $7 billion. There are larger estimates out there. This is just the smallest one in this report on post-quantum cryptography. So the size of the problem is significant, and it cuts across all critical infrastructures and gets into banking, healthcare. Every single one of the sectors is affected. So you ask, great, what do we do about this? So what solutions are available? And I'm going to talk about OnLogic and Patero in particular. So Patero has a product we call a crypto core. It's a software crypto module that runs on OnLogic hardware. And it provides a recommended solution, government recommended solution, what we call hybrid post-quantum encryption. And it's hybrid because it actually takes classical and quantum resistant techniques and it hybridizes them together. So we get a standard cryptographic key that is used with the math problem that we have today. And we use the next generation NIST standard to create a quantum resistant cryptographic key. And we hybridize those two keys together to create a session key. And that key is rotated every couple of minutes to ensure that the data is always encrypted with a new key every 2 minutes. So that's called perfect forward secrecy. Even if they could decrypt a 2-minute segment, that same decryption can't work in the past or into the future. And it's an agile solution because NIST has already stated they're going to issue additional algorithmic models that can be used to generate keys. And the reason NIST is doing that is because quantum computing is a new industry. AI and quantum is new. And AI and quantum and next generation classic computer programming, we expect there will be a need to rotate these algorithms over time. So that's what we call agile. And then on the zero trust component, it's really important that two devices will only communicate with themselves and not non-trusted devices. So we have a hybrid agile zero trust architecture, NIST standard compliant solution that works with OnLogic. That's a lot of buzzwords, but that's how it goes. So we talk about the zero trust and why we do that. We do it specifically because of that vulnerable attack surface I talked about. We want to reduce that vulnerable attack surface. So if you're streaming MQTT data from a manufacturing facility through an OnLogic device to an edge computing device or to a cloud application, one of those endpoints has to be listening and one has to be sending. We only want the listening device to respond to a known and trusted source. So what we call Patero, we call ghost mode, means that the listening device is effectively a ghost on the internet. It will not respond to stimulus from an untrusted device. It's unresponsive to scans. Remember I mentioned the 14,000 scans that GRU did recently against the 26 NATO countries? Those kinds of scans would not reveal a Patero trusted endpoint on an OnLogic device. And that's because we're using a packet level authentication, which creates this defense in depth network layer. So effectively, the black hatter can be asking an OnLogic device that's Patero protected to respond. Say, hey, is anybody there? Let me know who you are. Let me know what kind of encryption are you using so that I can attack you. But the OnLogic device simply will not respond until that secure packet, that authenticating packet is received. At that point, it will begin and the negotiation and authentication and generation of the quantum secure tunnel. So that's how it works. There's a simple setup with OnLogic. There's a software install on the device. It gives you a little console. You can type in the IP address and give it a name, and it will select the algorithm you want to use from among the NIST standard algorithms, and then it will automatically connect and create that quantum secure tunnel. And what that allows you to do now is take OnLogic devices or other devices with OnLogic is create edge to anything quantum private networks. And by doing so, you end up making your attack surface effectively invisible or reducing it to a point where common attacks won't work. And you're future safing using encryption that is post-quantum encryption. Now, you can do this across many different kinds of use cases. Here, we're just showing a simple system where you have various OnLogic edge gateways that are running IoT data from various manufacturing sectors. That data can then run over the open internet into either public clouds or private cloud data centers and be protected through what we call a quantum secure tunnel or a quantum private network. And so that's a very common use case that you would see into the wild. Another use case might be you want to create a quantum private data center where you have, say, advanced computing or applications that you don't want to run on a public data center. And you want to create quantum secure tunnels between various facilities and offices with your private data center. This is another way of taking OnLogic devices and building a secure architecture to give you private compute. Matt, back to you.
Thanks, Crick. That was fascinating. Thank you for giving us that overview. So we want to make sure we address, where do systems integrators fit in? You're likely asking, what does this mean for me? So we've informed you of what the risk is and how to identify it and what or where you should be protecting. But we want to make sure that this is an actionable webinar for you. So what we really want to do is, we mentioned several times in this session that our critical infrastructures are the most vulnerable to these threats. Now, of course, everything Crick went over, data in general is at risk, but we should really focus in on the areas that you all work in and day out. Our recommendation to you is going to be to not let the hardware and security be an afterthought, especially in the sectors you see on your screen. Food and agriculture, water and wastewater, critical manufacturing. They are the pillars of our society and what keeps the world turning. There are reliable and secure solutions available, just like the ones Crick presented, that can prevent these threats before they happen, and that's our goal here. And so OnLogic with Patero is ready to help you protect you and your end user from future attacks. With that, we would like to enable you with some common lessons learned and specific things to look for when architecting a solution. So let's talk about that. We want to make you a trusted advisor. So Crick, you went ahead and you provided some things to look for. Can you first talk about that first bullet there? Implementing edge to anything. What should integrators be looking for?
Right. So there's no doubt people are going to be implementing edge to anything data flows. And we also know already that at some point it's going to be critically important to have post-quantum encryption on those edge to anything data flows. So for any greenfield application, you would want to advise your clients that post-quantum cryptography is really, really important. And it's not important just in the future, it's important today for valuable data. So you don't want to be forced to a future retrofit when the regulation is released for your particular industry or your organization internally decides that they have to migrate. You can implement PQC today with a hybrid agile solution from Patero and OnLogic and be safe from steal now, decrypt later, but also be safe tomorrow when cryptographically relevant quantum computers are part of our daily fabric. And so that's really part of bullet 2 as well. We want to make sure it's safe as data is safe from SNDL attacks today and into the future. For example, it's common to use IPsec tunnels in many applications. IPsec is subject to quantum computer attacks as well. So you can do a retrofit on IPsec tunnels using quantum tunnels with Patero and OnLogic as well. And that's where I'm getting into bullet 3. And so that's really up securing the existing VPNs to future safe QPNs or quantum private networks. So as a trusted advisor to your clients, you've got a couple of opportunities to talk to them about securing the data that they have today against steal now, decrypt later attacks, particularly sensitive data, manufacturing sensitive data, anything that can be derived and used in competitive competitive way, or private data that could be misused in the future. And so these top three bullets are really important there.
That makes sense. Thank you, Crick. Now, what about cloaking endpoints? What can our users be doing to do that?
Right. So actually we skipped one, but I'll talk about cloaking and then come back to wrapping. So the cloaking endpoints is another important thing. So one of the most common attack vectors for the bad guys is they'll scan your network and they'll find a responsive port, an IP address. So when that port responds on that IP address, the bad guys now can ask that endpoint certain kinds of information, and by doing repeat pings or securing certain kinds of requests, they can often get that port to downgrade itself. So in fact, if you look at the bottom bullet and you're advising your clients on their networks, and it's probably they're using some TLS 1.1 or 1.2 still in the network. Those are protocols that can be negotiated down to an unsafe encryption level. So not only are you're talking about stealing now, decrypt later, but you're also talking about being able to negotiate existing endpoints out of a comfortable encryption into an encryption that can be broken with today's technology. So one of the things that we can do with quantum private networking is wrap that existing TLS 1.1 or 1.2 communication from an application to a user. And that will do is effectively block the access to these known vulnerabilities. Because if that TLS 1.1 or 1.2 protocol is being used within a quantum private network, it cannot be broken because you'd have to get through the quantum private network encryption to actually ask for those downgrades. And that goes back to the cloaking the endpoint. If the endpoint is now unresponsive because you've created a zero trust network architecture, the bad guys can't ping that endpoint to ask it to downgrade its encryption protocol on a TLS 1.1 or 1.2 or even 1.3. So those kind of things go together. And then going back to the wrapping protocols question, we often get this question and say, we're using MQTT or MQTTS to stream data from the edge to the cloud. And that's perfectly good protocol for using that. And you would ask the question is, well, do I have to change protocols? No, that's not the way it works. When we put Patero on an OnLogic edge device and Patero on a cloud endpoint, for example, what it does is it create a secure quantum private network tunnel. The MQTT protocol is used and continues to flow directly through that tunnel without any interruption. So we're wrapping existing protocols. Does that make sense, Matt? Does that?
Absolutely. You got to protect your communication means, right? And so that data has to get from point A to point B. So making sure that's safely secured to and from.
And that second to last bullet, the penultimate one, that's your bullet, buddy.
Yeah, no, absolutely. And so obviously the partnership with Patero is very strategic, right? We're trying to be just like you, forward thinking, and we want to make sure that we get ahead of the problem before it's a problem. And that's the whole idea in the way we design our edge gateways. And of course, making the hardware secure, making sure it's impenetrable to external threats, not only from physical security, but also software layer security is really important in that process. And so we're very intentional. In fact, we've actually developed a dedicated team internally to ensuring that we have zero trust hardware. We have are being very explicit in the way we design our hardware to ensure that it's safe from these external threats. Crick, your solution with Patero only makes us even better to making sure that the communication from point A to point B, that edge to anything, is connected in the process, or secured in the process as well. And then if you want to take us home, Crick, tell us about TLS 1.1 and 1.2.
Oh, I think that's I was covering that previously. We're talking about if you're using the cloaking the endpoints, then that endpoint is not detectable or responsive. And TLS 1.1 and 1.2 are still being used, believe it or not, in many networks. And so if you have a client that's using TLS 1.1 or 1.2, you may not want to rip and replace their entire infrastructure. What you may want to do is put a Patero protected endpoint with OnLogic in that network. And when you do that, you end up cloaking the endpoint so that the bad guys will not be able to get a ping response back from the TLS 1.1 or 1.2 endpoint. And that does is it prevents somebody from trying to negotiate those older standards down to a decryptable level. So that's what the point there is. So effectively, without changing your underlying technologies that are doing the communication, you can wrap those communications with PQC and then block access to those known vulnerabilities with the cloaking function.
Makes sense. Thank you, Crick.
Sure.
And I think just to make sure to kind of round this all out, again, I mentioned a little bit earlier, but the whole point here is really trying to get ahead of this problem and to not let hardware and software security specifically be an afterthought. And so I can tell you as the hardware expert and in OnLogic, we are extremely consultative when our customers come in and systems integrators especially is that we really want to understand your problem. What is it that exactly that you're trying to secure, and making sure that we get you in touch with the right edge gateway that's not only going to meet your needs from an application standpoint, but also from the environmental standpoint, because uptime is just as important as well. And then, Crick, if you can kind of give your perspective just in terms of if a systems integrator were to come to you, what's the process you would kind of take them through to make sure that they have what they need?
Yeah, absolutely. So when we work with systems integrators, we first ask them, what is the objective? Where are you moving data from and to? And where are those exposure points? Our focus right now is what I would call the exposed layer, the vulnerable attack layer, which is on the external part, the WAN side of industrial networks or healthcare networks, or et cetera. And so we focus there first to secure the communication flows from exposed edge to other exposed edge, rather than on the inside of the network. Insides of the network have other issues to deal with. So we start with that. We would work with the systems integrator to understand what those requirements are from point to point, what sort of protocol operating systems are being used, what are the cloud providers, what are the edge providers, OnLogic devices or other devices, et cetera. And then we'll provide them with the installation kits. They install, type in the IP addresses, and the things automatically connect, and off they go.
That's great. Thank you, Crick. And I think that brings us nicely to just really start to wrap up. I mean, everything that we've talked about here, obviously, that's a lot to absorb, a lot of important information, but the point is that we're getting ahead of that, right? We're trying to inform you and make sure that you're well aware of it before it's an issue. We also want to make sure that, Crick and I want to make sure you know that you're not alone in this journey in terms of learning more about post-quantum computing and how that impacts you and how to protect your data. So you'll see 2 QR codes on your screen here to learn more about our OnLogic Integrator program and also the edge gateways that we can support you with your solution. And of course, a link to Patero as well to learn more about their starter kit and how to get online with Patero and securing your data.
Matt, there's one other thing that people should understand is we talk about brownfield or existing networks, and you're asking about how to get started. We do have a starter kit, which you can read about on our website. But the other thing is understanding what your cryptographic inventory is. So you may have an existing network, to answer your question, is how do you understand where those vulnerabilities are and how to rank those vulnerabilities? And that's what's called a cryptographic inventory. And Patero can help you run a cryptographic inventory on the network as you're planning out your network upgrade for security purposes or adding edge computing on Logic. You can use that cryptographic inventory as a guideline or a guidepost in many cases for doing that work.
Very helpful, right? That not every project is a new project, right? So we want to make sure that we're protecting those folks who already have installments in the field, which I'm sure there's many. And then I want to also offer, Crick and I also want to offer our direct contact information too. If you want to talk more about this webinar or things that we discussed today, you'll find on your screen. And don't worry, this will be shared out more broadly if you're in the call now or watching this at a later time. But feel free to reach out. We're happy to talk with you. And with a few minutes left on the clock, we will open it up to any questions that we have from the attendees.
Just a reminder, if you do have any questions, please put it in the Q&A section that you'll find in the toolbar. But while we wait for any additional questions to come in, question here is, what is one key misstep to avoid from both the security side and the hardware side?
Yep. I'll take the hardware one and I'll kick it over to you, Crick, to address the software. Does that work?
Sure.
All right. So with hardware, we often find that we tend to underspec, or what we find, at least for customers, they tend to kind of underestimate either the quality of the build, whether that's the hardware level or maybe the environmentals that they're putting their system into the environment. Often either underpowered from a compute standpoint, maybe there's a temperature or a dirt and dust ingress issue that maybe wasn't fully addressed or thought of before putting that in. So I think I mentioned just a bit ago that we're highly consultative. We're going to ask you a lot of questions when you come in, and just really make sure that if you have already identified a solution, or if you need help identifying a solution, we have a fleet of internal resources on the engineering front that can help you make sure that we've checked all those boxes to make sure that we're not only covering you just from the basics, compute, memory, storage, but also considering the environmentals, considering any regulatory needs, considering the security aspects of this. Do you need secure boot? Are you putting this into a zero trust environment? We will start to ask those questions, and then get you aligned to make sure that you have the right edge gateway for the job.
Yes, and similar, Matt, the thing that people are just learning about is the need to consider post-quantum cryptography in their network architectures, both in a brownfield application, but also in greenfield applications. The consultative approach you referred to, Matt, is really, really important to understand what is the threat, and is the threat relevant for each piece of a network. And it may not be a threat that you need to prioritize, or a portion of that network that needs to be prioritized, but it may be something that's really, really important. So becoming aware of the opportunities, or sorry, the need for implementing post-quantum cryptography, and the opportunity that you have to very simply create these quantum private networks would be the thing that we would advise people. Just take a few minutes, ask us a few questions, and decide if it's something you guys need to be considering.
Great, thank you both. We do have a question that came in from one of our attendees, and this is for Patero. How quickly can this be implemented, and what type of point of contact is available?
Is that proof of concept or point of contact? It's
probably proof of concept. Yeah, it's POC, but probably proof of concept. Yeah.
Yeah, fair enough. Yeah, so the crypto modules is something that can be, we can deliver the crypto module and you can run the install on that crypto module. Of course, it's like a telephone problem. You have to have two telephones to make a conversation. So you would install the crypto module on one or both ends, on both ends of the communication. There's a user interface that is part of that, and the IP addressing, either you can give it to us ahead of time and we can deliver it so that it instantly connects, or we can let you type in the IP address and choose what parameters you want for the cryptography, and those endpoints will connect. So it's pretty straightforward. Our consulting team will walk you through the process, and we do have what we call a Patero Go. Patero Go is a proof of concept. It's listed on our website. I recommend you take a look or send me an email, but it's a fixed price type of deal with an X number of endpoints. We can either provide pure software endpoints, or we can work with a partner like OnLogic to deliver pre-installed software on gateways that you can use in your network or your laboratory to test, improve, and build your solution for your client.
Great, thank you. And we'll just do one more question here. How can organizations evaluate the return on investment of implementing security solutions like those offered by both of you? And what factors should be considered when making purchasing decisions?
Yeah, I'll take this one first. So in terms of hardware, it's a very similar story. It's just making sure that you're making the right investments, right? It's the total. We always look at, and we always look at the total cost of ownership. It's very easy to make sacrifices, or maybe say, now, do I really need something that hardened? Do I really need something that necessarily maybe premium when compared to other computing solutions that are out there in the market? We have not only a US-based team here in Burlington, Vermont, and also in North Carolina, but we have a lot of dedicated resources right here in the States to make sure not only you're getting technical support, but really high-quality engineering, high-quality sourcing in the components and the quality of the engineering to make sure that your system lasts in the field. And that right there is the ROI. We have MBTF data, we have technical support data, we have failure data that we can share that really shows that when we say we have reliable hardware, we mean it. And that alone, you can also look at the customer success stories and the testimonials, hear it from other people other than ourselves that say, this really has saved me tons and thousands, sometimes hundreds of thousands of dollars in a calendar year because of the uptime that they've seen by moving to an OnLogic Edge gateway. So that really is where we see customers coming to us where they say, we can tangibly say that we have saved money by switching to your hardware because of the quality of that device.
Yeah, and I'll jump right on that total cost of ownership bandwagon. We have multiple architectural implementations that we've done for clients that will reduce the total cost of ownership, not just from a hardware security standpoint, but from an operational standpoint. One of the benefits that can be realized by putting in a quantum private network is creating remote access, secure remote access, which allows organizations to either provide specific access with crypto routing to individuals who need access to a particular machine or particular application without having to come on site or sending truck rolls to do maintenance, etc. So using quantum private networking with either OnLogic devices or through cloud endpoints, we're able to create architectures that will improve the speed and efficiency of operations and increase the security of, if you think about it, the zero trust architecture and crypto routing, we can give specific individuals or organizations access to very specific components within the architecture of your network, and then your total cost of ownership is reduced. That's an example.
Great. Thank you to both of you. On behalf of CSIA, I would like to thank our speakers, both Matt Smith and Crick Waters, for this informative discussion. I would also like to thank OnLogic and Patero for sponsoring this event. And of course, thank you for attending. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thank you for joining us and have a great day.
Thank you, Jill.
Thank you, Jill. Thank you, folks.